This module introduces the coil tubing unit. The coil tubing unit is a well servicing unit utilized for many different well operations. The use of coil tubing, highly flexible hose-like pipe, allows for much greater operational flexibility than many other servicing methods.
During production operations, the operating company constantly monitors several important parameters. Most significantly, the hydrocarbon production rate is monitored. How much oil and gas are being produced by the well and how quickly. When this well production rate decreases, it is typically due to a problem with the downhole formation or an issue with the well. Well servicing is frequently utilized to help solve these production issues and increase the rate of flow. Let's take a look at a few scenarios. When producing, our goal is to just produce formation fluids, ideally just oil and gas. However, generally, small pieces of rock from the formation are also produced along with the oil. For example, when oil is produced from a sandstone formation, sand is often produced as well. This sand can clog the rock fractures and tubing perforations, slowing production. Similarly, completion fluids can cause clay to become a thick paste. This paste collects on the inner walls of the casing and restricts the flow of oil into the production tubing. Many other substances such as paraffin and wax can become stuck on the sides of the tubing. Any of these blockages slow the rate of oil production to the surface. There are several different well servicing strategies that can be used to remove or clean out different types of blockages in the well. Some of these aim to prevent blockages from occurring in the first place, while others are focused on removal. Gravel packing is a sand control method used to prevent sand from flowing into the production tubing. Gravel is pumped in between the production tubing and the casing of the perforations. Gravel acts as an additional filter to restrict the flow of sand into the tubing. Another common method of sand control is to use gravel pack screens. Screens are placed at the perforations and restrict the flow of sand into the production tubing. Oil and gas can flow through, but sands of particular sizes are blocked. Acidizing is a servicing procedure in which acids are injected into a blocked formation to disperse clays away and make the oil flow freely again. Tests are run on the formation, and the crew figures out exactly which acid would be most effective for the particular well situation. For example, when your shower drain gets clogged, an acid may be used to help. The acid in the cleaner helps disperse the materials blocking the shower drain, breaking them into pieces and letting them flow. Similarly, during acidizing, acids injected into a clogged formation disperse the clay particles and thin down the paste. Oil can freely flow into the production tubing, improving the production rate. Lastly, many obstructions are removed by just pumping fluid directly into the well at high speeds. The fluid pressure forces the obstruction away. In addition to blockages, a reduced flow rate can also be caused due to formation problems. Often, these problems result in too much water being produced instead of oil and gas. Typically, a formation may contain gas, oil, and water. Because of the different fluid densities, gas is typically on top, oil in the middle, and the heavy water on the bottom. When we create perforations in the formation, these are designed to be as close to the oil and gas layers as possible. We want to produce oil and gas, ignoring the water. Over time, As more and more oil and gas are produced, the total amount of fluid in a reservoir decreases. The layers of oil and gas, at the top of the reservoir, are no longer completely full of fluid. The top layer, with oil, is not completely full. But, the bottom layer, with water, is still full. This creates a vacuum that sucks water upwards. Water coning occurs when water is pulled upwards by this vacuum, replacing the flowing oil. Water flows into the well in the shape of a cone, reducing the oil production rate as water is produced instead. Water coning is problematic, because our goal is to produce oil and gas, not water. If too much water is produced, it can destroy a reservoir's potential to produce hydrocarbons. The main reason for water coning is producing oil at a very high rate. The faster oil is produced from the reservoir, the stronger a vacuum is created. As a result, more and more water is sucked upwards and produced. To resolve water coning, one option that may work is to temporarily shut down the well, or lower the production rate. With the well at rest, or moving slower, water will slowly settle back down, to the bottom of the reservoir. In more extreme situations, another option that may work is to plug the existing perforations with cement, and reperforate the entire formation. Let us now look at another reason for stimulating a producing well. Recall that perforations are made in the well to start production operations. Perforations create fractures in the formation that allow oil to easily flow into the tubing. Over time, much of the oil in these perforated fractures can become exhausted, reducing the flow rate. To continue well production, these fractures need to be extended and expanded. Hydraulic fracturing is a process in which fluids like water, acid, and oil are pumped at very high pressure into existing formation fractures. The high-pressure fluids increase the length of the fractures, allowing oil to move more freely. As a result, the production rate improves. Sometimes, well equipment may also suffer damage due to intense downhole pressures and temperatures. This can include downhole packers, valves, and even strings of pipe. Well servicing can be used to remove this faulty equipment or service it using different downhole tools. In some cases, equipment failure downhole can lead to equipment being lost in the wellbore. Tools, piping, and other equipment can all become lost and stuck downhole. During well servicing, fishing operations can be utilized to pull the equipment out of the well. The most common tubing problem is junk stuck in the hole. A piece of equipment, a tiny amount of rubber, anything stuck in the well can force all servicing operations to a halt. We may see a considerable decrease in the production rate depending on the size of junk. The solution to trapped junk in the hole is fishing. During fishing operations, the crew uses different tools to identify and remove fallen junk from the well. First, the crew runs an impression block into the hole on wireline. When it hits the object, the block will record an impression of what the downhole object, or fish, looks like. This way the crew can understand exactly what the object is, its orientation, and what the best tool is to remove it from the hole. Then, the crew will lower a tool on wireline to actually pull the junk out of the hole. These fishing tools are managed by a fishing supervisor and can actually grab and pull the junk out of the well. Similarly, recall that cement is used to plug and support different parts of the well. Over time, this cement may become damaged by intense formation pressures. Cement repair jobs are carried out to rectify cement damage. During servicing, a cement slurry is forcefully pumped or squeezed into damaged area of the well bore. When the slurry dries, it fills up any cracks or splits. When a well first starts producing, it has the highest reservoir pressure, causing fluid to flow easily and swiftly to the surface on its own. However, over time, the amount of oil and gas decreases, and the reservoir becomes less economical. After years of producing oil from a reservoir, a time comes when no more oil can be produced without spending too much money. A decision will be made to plug and abandon the reservoir. Sometimes, a depleted reservoir is shut by plugging it with cement. Recall a cement slurry is a mixture of powdered cement with other fluids like water. Cement slurry is pumped downhole to block the fractures of a depleted reservoir, shutting it down for good. This is known as a cement plug. Other times, if a cement plug is not possible, a mechanical plug is used instead. A physical plug is lowered downhole and is set into place. Recall that some wells have multiple reservoirs with hydrocarbons, at several different depths. Usually the lowest reservoir is the first one to be produced. Using well servicing equipment, this new formation can also be completed and can begin production operations. In many cases, if a sliding sleeve had been installed, the sleeve can be activated to allow for flow from the new formation. Production continues from this new reservoir until it too runs out of oil and the same plug and new completion procedure is carried out. This way the same well can continue producing for many years.
During production operations, we are constantly producing oil and gas fluids from the hole. Sometimes, during this process, we run tests on the reservoir we are producing from. The goal of these tests is to discover more information about the reservoir. How much oil and gas does the formation contain? Are there any problems downhole? Often, wire line is used for well logging operations. However, in some cases, especially in challenging or deviated wells, coil tubing can be used to conduct logging operations. Coil tubing is much easier to use to traverse highly deviated wells than wireline. Lost circulation is when fluids from the well enter the formation. In addition to harming the underground formation, this also reduces the amount of fluid present in the well. During different well situations, such as drilling, this can cause well particles to become clogged at the bottom of the well. This can cause the pipe to become stuck and bring operations to a halt. Well servicing, and coil tubing in particular, can be used to circulate this blockage out of the well and allow normal operations to resume. Coil tubing can be useful in selectively targeting a specific area and putting high pressure on a blockage to remove it. Recall that a kick, in a balanced well, is the flow of undesired formation fluids into the hole. After a kick occurs, killing the well is the process of removing the kick from the well and resuming normal operations. Because coil tubing allows for fluid circulation, it can be very useful during well kill operations. Fluid can be pumped through the coil tubing to circulate a kick out of the well or to increase the density of well fluid.